Yes, sir, you can start now.
Okay, thank you, Shajan. So, this is Sathish from Chandhar Research Labs. Today, I am going to present video demonstration for fading phenomenon fading impairments in mobile communication. So in this presentation, okay, our video demo is going to consist of three parts. Okay, in the first part, we are going to introduce the Troy app and CRFO website. So how we are going to collect the data using Troy app and feed this data in the CRFO website, and how to create the radio coverage map over the whatever the measured location. In the second part, we are going to introduce the Shadows app. So using Shadows app, how you are going to record and measure your RSRP values. And third part, live demonstration of small scale fading using WiGi equipment developed by the Chandhar Research Labs. So with this, we will move on to the basics of regarding this fading phenomenon in mobile communication. So basic phenomena are nothing but path loss. Okay, so path loss is nothing but the signal attenuation. Okay, and fading, you all know two types of fading: shadow fading or large scale fading that represents the log normal distribution, and small scale fading or multipath fading. Okay, it represents two distributions: Rayleigh distribution and Rayleigh distribution. So with all those things, just we will see the fundamentals in 2-3 slides, then we will move on to our live demonstration. So first, path loss. So the path loss for a receiver, average path loss for a receiver located at a certain distance d is given by average path loss. So that's why PL average at a distance d is given by d divided by d naught the whole power alpha. So d represents the distance, whatever it is varying. Okay, and d naught is nothing but your close-in or reference distance. Alpha is nothing but your path loss exponent, and always your close-in reference distance d naught should be greater than your Fraunhofer distance. Fraunhofer distance, you know, it is always, df is always greater than equal to 2d by lambda. That is, the distance should be the largest than the your physical dimension of your antenna. The same path loss expression has been expressed in the dB scale. Okay, shadow fading. So shadow fading is nothing but the average residual power at a distance. So shadow fading is a large scale fading. So over the larger distances, how your signal fades. Okay, so average signal power is given by received signal power. Average received signal power is given by transmitter power minus your path loss. So the received signal fluctuates around your mean value, okay, at a distance d. So this mean value is given by this epsilon. Okay, this is nothing but a zero mean Gaussian random variable. It is again, epsilon is also expressed in dB because this complete thing is in linear scale dB. So the this epsilon is also represented in dB with a standard deviation of 4 dB. So you know, two environments are there, whether the urban, cellular or rural scenarios. In urban scenarios, your deviation is 4 dB, whereas in the rural scenario it is 12 dB. And you know that the PDF of the shadow fading follows the exponential distribution. So exponential distribution expression is given here. So with this, okay, now we are going to go for the data collection. That is the first part of our video. So first thing is data collection we are going to do. So LTE received signal strength. So first we are going to select your cell, okay, and from the particular cell. So the cell here is, we are referring to our BTS or base, whatever the nearest cell tower, it is located here. So whenever the cell tower or the base station, it transmit the signals, or you are going to measure the transmitted signal, normally you measure the signal in terms of your RSRP, that is reference signal received power. Okay, so this reference signal received power is nothing but it is the average or total received power observed in your OFDM symbols over your n resource blocks. The second parameter is received signal strength indicator. So the received signal strength indicator is nothing but the average power it is covered over your OFDM symbols containing containing the reference signals over the end resource blocks. Your RSRP, reference signal reference power, is nothing but the linear average power over your resource elements. Contributions of all the power, it is taking the average of that power. Next, the third parameter is nothing but reference signal residue quality. This is a mathematical parameter. This reference signal residue quality is based on first two parameters, RSRP and RSSI. So RSRQ is nothing but it is equal to n, the number of resource block elements multiplied by your RSRP divided by your RSSI. So here I have mentioned a table, okay, the RSRP values. So it's starting from 00 to 97. So every 1 dBm, it is given a RSRP value numbered from 00 to till 97. And this table is taken from this table is taken from the reference blog ARIMA 78 RSRP and RSRQ measurement in LTE. Okay, so with this, with this, first what we are going to do is, first you should we are going to collect our data using TROI app, that is Telecom Regulatory Authority of India. So if you see this, okay, so first I'm going to install the app TRAI, TROI My App. Okay, so here you can see TRAI My Speed app. Okay, this is similar to many apps available in this one. So I feel this app is user convenient to measure my RSRP values and my my network uplink speed and downlink speed. So first what you are going to do is first go to the Google apps, okay, download TROI My Speed app. Okay, so before switching on the app, make sure that your Wi-Fi is on, your Wi-Fi is off, and your mobile data should be on, and also your location should be on. Okay, so there should not be Wi-Fi network, your mobile data and location should be turned on. Okay, so now my mobile data and my location both are switched on. Now I'm going to TROI My Speed app.
Satish, can I interrupt you?
Yes, sir.
Are you presenting another window by any chance?
Yes, sir.
Apart from your presentation?
Yes, yes.
So are the participants able to view it?
Okay, one second. Okay. Now you able to see the window?
Yeah.
Okay. So this is my mobile window screen. Okay. Oh, hello. You're presenting. Okay. Okay. So now you can able to see the video. Hello.
Yes.
Yeah. So
Yes, sir.
Yes,
sir.
Okay. Okay, you can see that. So this is my mobile window screen. Okay, here, one second, sorry. Okay, this is my mobile screen window. I installed the app TROI My Speed app. You can go to the Google app and you can enter this name TRAI My Speed app and you can download this app. Okay, before opening this app, make sure that your Wi-Fi is on, off, and your mobile data and your location. These two things are on. Okay, there should not be your Wi-Fi network, your mobile data and your location. Okay, so now both these things are on. Now I'm moving on to my app. Okay, so I am clicking on my TROI My Speed app. So the TROI My Speed app is open. TRAI, this is nothing but, okay, Telecom Regulatory Authority of India. So using this app, it is a user-friendly app and it is very convenient. You can measure 3 different data. One is your nearest base station. So wherever you are located, you will be having one base station near to you, either a 2G or a 4G base station is near. From the base station, you can start receiving the signal and you will be knowing your RSRP. Well, this one thing. Suppose if you are having a 4G connection, so you'll be enjoying your internet or your data experience also. So for the particular internet, you can measure your uplink speed as well as your downlink speed. Okay, so first what you are going to do is, this is the start page of your app. Okay, so in this start page, okay, my network is Airtel network, so I'm getting my Airtel. I'm a 4G user, so my 4G is applicable here right now. Okay, I didn't start my test here, only begin test is there. I didn't start my app, so NA, my RSRP value is not applicable, and the unit of my RSRP is dBm. Okay, now I'm going to begin my test. I'm just going to click on this begin test. So just see what is happens. Okay, so it starts searching for the signal. So if 4G signal, so something fluctuating from minus 107 dBm and something like. At the same time, simultaneously, whatever the signal received with the RSRP value, it is measuring for my download speed. Now it is move on to measure my upload speed. So here it is showing my uplink network speed, okay, uplink speed, and previously it measured for the downlink speed. So once after measuring, so in this window, okay, Airtel network 4G LTE for this particular RSRP values. So when it is continuing the test, okay, that time you can see the RSRP values fluctuating, and as a result it takes the average of that RSRP value, or it gives the strongest of the RSRP values, and it has been displayed here. It shows the date and time, okay, when I begin the test, okay, date, time, and this gives the satellite latitude and longitude at what particular location I measured this RSRP value. Then this downlink speed and uplink speed, unfortunately I'm not getting any network delay and packet loss. So wherever location you are, you can also download this app and you can collect this data. So this is one test. So this app, okay, we have done this app for two things. We have measured two different tests. Okay, one, what you can do is you can cover a distance from 10 kilometers and 20 kilometers or whatever is, you can go for what are the base stations located in that particular area. Every base station you can go and you can collect this data. So based upon this data, you can come to a conclusion that which base station is giving you a better uplink downlink speed for your data experience, and which signal is giving the better RSRP value for whatever is. So you can go for 10 or 12 different towers. For every different towers, you can measure this and you can find out which tower signal is giving you the best experience. This one experiment you can do. Second thing is, you can keep one tower fixed, whatever the tower nearest to your location, wherever, or your home or your office, you keep that particular tower as constant, okay, but you surrounding that tower different locations you capture, so that here you're monitoring the performance of a single base station, how the single base station at different angles, at different points, okay, close to the tower or very far from the tower, at if suppose the tower is covering some 10 or 12 different streets, each street you can go and you can measure. So at different sectors of the antenna, you can measure how the performance of that particular base station. So like this, you can take n number of readings. Okay, so you can do any one of the tests, whether you can cover a 20-meter distance, whatever the base stations, 12 base stations, you can record the readings of the 12 base stations, or else you can keep one particular base station. Around one particular base station, you repeat for n number of readings, and whatever you can do. So here you can have some icons are presented here. So in this first icon, it is used to begin test. If I click this, okay, it will go to the first page. So you can go and take the further readings. The second thing, you can see dot and slash. Here it will go and record the history of your complete test, whatever you have taken. For example, just I'm showing you. Okay, so again I'm doing the second reading I'm taking. So second reading, again it is showing an RSRP value of minus 111 dBm, and it is searching for the downlink speed. So it is showing 0.01. That means very poor downlink speed. That means what? At this particular time, particular location, the data is peak data is arrival. That's why there is no downlink speed. Even the upload speed is also very, very low. Okay, so at that particular time, the data you can see here, the downlink speed and uplink speed are 0. Only it is showing you the RSRP values. So it depends upon the time. Suppose if you are measuring the same thing in the peak environment or peak time, then you won't, or if you are not receiving any downlink data, you can see in your mobile 4G, two lines will be there, uplink and downlink. Sometimes you can see you can see now that one window is going. That means at that time you won't get any downlink data, download data. That time the download data will be 0.01. So sometimes both the lines you won't be getting. There will be a 4G connection and both lines won't be visible. That means what, you know, you're not getting both upload speed and download speed. That time that values will be 0.01 or 0 Mbps. That is what dictates, and it shows the latitude and location for every reading you are monitoring. So with this, okay, if I press this icon, okay, this icon, I'll get this window, this dot 3 line. So I have taken n number of readings at 15:10 this particular time, this one. So here it shows my Airtel operator, okay, and it shows my downlink speed and uplink speed. So if I click on this particular reading, then it will go on to this main page, whatever this display window you got here, okay, this window you will be applying. So if you go to this window, then you can measure your RSRP, latitude and longitude, everything. So whatever the reading you want, you click on this particular reading, that reading will take you to this main page, okay. There you can take all the informations, RSRP, latitude, longitude, your upload speed and download speed. When you see in the history of readings, suppose this readings, history of readings just will give you the date, time and upload speed and download speed only. If you want your satellite location and RSRP, you want to click this, then it will take you to the main page. So like this you can repeat your readings for 12 base stations, or keeping one base station you take 12 different readings. So now using Troy My Speed app, I started collecting my data. I know how to track the history of my data. So with this, okay, just a minute. So I'll give you a 5 minutes time so that you can install that app and you can try whether you can able to do the same. So just take a 5 minutes break, try to download this app and try to check whether you are getting your own RSRP value and uplinks, upload speed and download speed from the nearby base station. Okay, so we'll meet after 5 minutes. Please do it right now.
Satish, there is a query by Vic, that is, what do the red and green points in the map represent?
So sorry, I'm not clear. Can you repeat it again?
Yeah, you can hear me now?
Yeah, now I can hear you.
Okay, so there is
Hello?
a query by a participant as to what do
Okay.
the red and green points in the map represent?
Okay, red and green points. Okay, so when you are measuring your RSRP value, it is showing some values from minus 70 dBm to minus 110 dBm. So we will consider the low values and the high values. So minus 70, you assume that that is the lowest value. That means you are very, very close to the base station. That means whatever the signal you are receiving, it is a direct LOS signal, or the received signal strength or that particular RSRP is very good. That is the green color thing. Okay, suppose the red color thing, suppose you are getting the very lowest value of minus 100 or minus 110. Okay, so that is the very, very lowest value. So lowest value means very, very weak signal. Okay, that means you were sitting inside some building, whatever the signal that has been blocked or diffracted or reflected, or it can be your non-line of sight signal, whatever else. So that is a very weak signal. So I have taken some 34 measurements. Okay, out of the 34 readings, okay, this green color are the thing that gives a very good signal RSRP values, that is ranging from minus 70 to minus 80 or minus 85, and this red color values are very, very weak values, minus 99, minus 100, minus 110, that particular values. Any doubt?
Yeah, so I think the
So how many of
values,
you downloaded the app? You can able to do the same things?
yeah, I think I'll give them some time. As I said, I'll wait
Okay.
for 5 minutes and yeah.
Okay, fine. Prabhu, Prabhu.
Satish sir, there is a query in the chat box.
I have seen the query, just I'll answer you.
Okay.
So you are asking what about the comparison performance? Okay, actually for our video presentation that compare performance is not required. Okay, suppose if you are interested, it is just to visualize. Suppose every location. Suppose if you are in whatever place you are, you can compare the performance of your network operators, different network operators. Suppose sometimes your base station will be shared by 2 or 3 operators. Airtel and BSNL will be sharing the tower by having their own separate antenna. So that time they are comparing the two signals, or sometimes people will be using 2 SIM cards in your mobile phone, right? So you are comparing the performance of the two SIMs. So Airtel SIM will receiving a RSRP of one particular RSRP value, and your other BSNL SIM will be receiving another. So if you are comparing the performance of these different operators over the single location, then you can go for this compare performance. Okay. One more question is from Budatya. How you know about the angle at which we are taking measurements with respect to the base station? Sorry, Budatya. With this app, we can able to measure only our RSRP values, and we are not there's nothing related to the angle of arrival of your received waves and everything. Okay. Okay, right now it is not possible. Right now we are measuring only the RSRP values. Okay. Regarding this angle, okay, we will discuss in the second step of whatever the data. Now we have collected our data. So using this data, how we are going to create the radio map. That time I will tell you about this angle. Just wait for 2 or 3 minutes. Okay, so many of you are trying, so we'll continue with the session, no problem, you can try later on also. So with this, okay, the first step is over. So using the Troy app, you collected your data. Okay, now, okay, soon we will be mailing you one .csv file. Okay, .csv file is nothing but the modified form of Excel file. There will be 3 columns. Okay, latitude, longitude, and your RSRP values. That means latitude and longitude means it is specifying at what location you are measuring that your RSRP values. Just from the mobile phone try up from the history of the readings, you are going to feed your data in the .csv file. That means you are creating an Excel file of whatever the readings you are taking. Suppose you would have taken 10 readings or 12 readings. All the data, now you are going to feed it over the .csv file. Okay. So after this, the second step is, so first step is data collection using Troy MySpeed app. Second step is we will be sending you .csv file in the link. In that link there will be three columns. Okay, location, latitude, longitude and RSRP. So in that latitude, location, RSRP, you just enter your own values. Okay. Once again I'll show you the model of that particular thing. Okay, just one second. Okay, you don't show. Just one second. இதுல .csv file வந்து இங்க தான இருக்கு. இவ்வளவு நேரம், இது ரொம்ப நேரம் ஆகுது. ஓகேவா, இதை நமக்கு நீ அனுப்பு. ஓகே ஓகே ஓகே, இது இன்னும் வரலையே, டேட்டா ஷீட் வரல. டேட்டா ஷீட் வரல. present. Hello. Okay. So now you can see this text format or your .csv format. Okay, this is nothing but a Excel sheet format. Here latitude, longitude and the value is given. Okay, so these are the for 34 locations or 32 locations. Okay, I have taken for every particular reading. I have taken my particular latitude, particular longitude, and this is my particular RSRP value. So this you can do. If you are going to do for your RSRP values, then type all your RSRP values. If you are going to see the downlink speed of your internet, then type all your downlink speed. Or if you are going to do the test for your uplink speed, then enter your upload data, whatever else. Latitude, longitude, it is going to be same. Whether you are going to enter RSRP value or upload speed or download speed, your latitude, longitude is going to be same. One thing is you should keep in mind is whenever you are entering your latitude and longitude value, you should not round off the value decimal to 2 digits or 3 digits. Because if I'm going to take a reading surrounding a single base station, then I'm going to vary around some 500 to 600 meters. So every 500 or 600 meter, I'm going to take one new reading. So that time what you have to do is you want to enter the entire latitude, longitude position. So whatever the digits present after the decimal, whether it is 8 digits or 7 digits or 10 digits, enter the complete digits. Because this Chennai Nagar is located in Chennai. Chennai latitude, longitude is 113 degree latitude, 80 degree longitude. That's why all the readings, if you see, even after the decimal till 2 digits or 3 digits, it is almost similar. So whenever you are entering a latitude, longitude, try to enter the complete value. So now data collection over, data I have entered in my Excel sheet, so my data sheet is ready. Okay, this data now I can upload and now I can create my radio coverage map. Okay, so 2 steps is over. Now we are moving to the third step. Okay, so before going to the third step, okay, I would like to share one more video. Just wait for a minute. Okay, so there was a link, Chandhar Research Labs. Okay, there was a email link. Okay, you can click on that link and you can take that format .csv format, whatever is shown you. Okay, you can take that, and in that my own readings have been entered. Please clear all those readings and try to enter whatever the readings you have recorded in your app. Okay, otherwise if you are using the same thing, then you are creating the radio coverage map for whatever the location I am sitting over. Okay, just re-enter your own readings. Okay, delete and enter your readings. Okay. um, Okay, so now two step is over. Third step is, now we have created our data and we have a .csv file in our thing. So 12 or 10 locations we have all the readings. So using this reading, how to create our radio coverage map. This is our next goal, third step. So for that, you go to your browser, okay, go and type the link www.crfo.org. Okay, crfo.org. So just note down this link. Later on you can do it. Just listen how I'm going to do on this link. Okay, so the CRFO is nothing but Collaborative Radio Frequency Observatory. So observatory means it is like some repository. Okay, so the same thing, it is an online observatory. It contains the radio frequency measurements from various locations in India. So I am from Chennai, my location says somebody is from Goa, whatever the place, your own locations, major locations or major cities locations, it will be uploaded in the website. So the main purpose of CRO is to enable the collaborative research and development in the field of wireless communication in the cost effective manner. Okay, now what is CRFO? It is clear. So what are the applications of the CRFO? So the major applications of the CRFO are, it is a national level spectrum monitoring. So you can monitor the spectrum wherever else, Chennai, Delhi or Bombay, what are the major cities, you can monitor the current spectrum whatever it is at the particular location. Next you can see the dynamic spectrum axis. If you are going to do any cognitive radio related applications, for that you can use the CRFO. Okay, and you can develop any machine learning tools in the field of wireless communication, or if you are going to do any online projects with respect to machine learning and wireless application, you can use this too. And for teaching advanced signal processing and wireless communication algorithms, so any modeling kind of thing, you can use the CRFO website. So okay, now this is the main page of the CRFO website. Now what we are going to do, so there you can see the four major icon in the website. One is home, next one is CRFO map. So click on this CRFO map. Okay, if you are a first time user, then it will be, there is an option called login and register. Just click on register. Okay, you create an account using, create your username or password, or you can use your Gmail ID, you can create an account. So first click on the CRFO map. Okay, it will show you username, password. For example, I think after clicking here, now you can see, okay, it is welcome to the CRFO login. Since I have registered already, it is showing only login. If you are a new user, then there will be one more icon, register. Click on register, create the link. Okay, so after creating, then come to the same home page, click on the CRFO map, you'll be getting this page. So in the login page, click on login. Okay, you will be entering into the CRFO. So I have signed in with my Google ID, so sign in with Google. Okay, welcome to the CRFO map. So I'll just stop here. I'll give you 2 minutes. Okay, register in the CRFO link, create your login, and make sure that you are also getting whatever the page I'm showing you. Okay, just take few minutes, 2 or 3 minutes. So if you are able to register successfully and you can able to log in, please reply me.
Yes, sir. I can.
Okay, fine. So I got one as reply. Okay. Okay, fine. So four or five people have logged in successfully. So I'll continue with my presentation. Okay, so now if you see here, so this is the CRO website. So first you see the left side. So left side some icons are there, right side is nothing but our India map is there. So in this state, okay, you can select your own state. Okay, see if in the selected state, okay, I'm from Tamil Nadu, so I'm selecting my own state. You can select your own state. Done. Next, center means mostly this will be the cities, Chennai, Bombay or Goa, like that kind of cities. So I'm selecting the center. You can select your cities. Okay, here one thing you have to keep in mind. Okay, here already we have took the test, we have created the data and we have uploaded the Chennai Nagar. So that's why it is showing the name Chennai Nagar, Chennai. In your case, it may not show you the particular area. It may show some Chennai. If you have uploaded the data, then it will be showing you. Otherwise, first time you are going to create this one. Okay. So after this, okay, go to location. Click on go to location. So I'm going to click on go to location. After selecting this one, it will go to locations. For example, yeah, go to location. Yes. Okay. Okay, go to location. Now you can see one middle window. There you can see the cellular spectrum allocation. So that means in Chennai, Shenonagar area, so I am at one particular in my lab. Around my lab, these are the base stations or the signal tower, whatever it is around me. So I have one Vodafone tower operating in the band of 2100 and uplinks frequency, downlinks frequency is visible. And one more tower, Airtel tower, I have it that corresponding. So these are the whatever the towers present around me in that particular location. Suppose if after clicking your area, if this is not visible, then that particular data is not uploaded here. So some of you from the remote locations, okay, you not me from the major cities. That time, if the data is not uploaded, then you were unable to see this particular information. Particularly for major cities, you will be getting this information. Okay, so with this, next information is activity status. One below that there is an activity status. Okay, what this activity status? I'll tell you the x-axis and y-axis. So this y-axis is nothing but the frequency. So frequency starting from 0 megahertz to till 5 gigahertz or till 6 gigahertz. It has been given here. And the x-axis, it is giving from 0 to 200 seconds. So that means it is a data for roughly some 3 to 4 minutes or till 5 minutes data. So at every second, it is showing the some spectrum. And if you see here, this black colored dots, there are some active transmission, active spectrum present. And this white spaces, that means no spectrum or no frequency is present there. And you know that around 500 or 0 to 500, you have some AM stations. So because AM stations frequency starts from 550 kilohertz to 1720 kilohertz. So if you see between those frequencies, there might be some AM stations. And also you know that FM station frequency is from 88 to 108 megahertz. So whatever the frequencies present here, this might be some AM or FM stations. Next, around 1G. You all know that 2G frequency, everybody is using 2G GSM. So it is something 935 to 960 megahertz and 920, okay, 935 to 960 is a downlink frequency. So around 1000 megahertz, this is somewhere some 900. So these are my active 2G frequencies. And around 2000 or 2.4, here there will be some Wi-Fi bands, or around 200 some LTE bands will be present. So these are the active LTE bands. Okay. And similarly at 500, okay, there are some active bands present here. Okay. So with this, Okay. Okay, below this, you can see the percentage of the same figure we are showing in this. So it shows that these are this yellow green color line shows the major active transmissions, and this blue color line represents the inactive transmissions or unused runs, whatever is. So whatever in the first diagram I shown you, the same thing it has been shown here in the color plot diagram. Okay, so if I select my state and center and go to location, whatever the location I'm present, I can see what are the towers present around my location, or whatever the base station I'm accessing, and that whatever the frequency or whatever the used spectrums covering from 0 to till 6G, what are the active transmissions present around me, everything I can able to visible. Okay, this is the first thing of this particular website. But our cases, now we have already created the data using Troy app, and we feed the data in the .csv format. Now what we are going to do here is, here one more option is there below this location. So you can reset and you can go for any location, and you can see the same cellular spectrum access, active status, and percentage of occupied bandwidth. You can see for any locations if it is been uploaded in this site. Now what I'm going to do is, I'm going to upload .csv file. So just click here, browse file. Okay, just click it. It will ask for the upload. So you have already prepared your .csv file, whatever the test you have taken. You just upload that file here. Okay. So this is what is shown in the video. Okay. Okay, this is a data.csv file I have. Okay, I'm uploading the .csv file there. So I'm just giving okay. So all my latitude, longitude value is there. I have uploaded my, okay, all my latitude, longitude values, and my RSRP value I have taken. That's why minus value. If you are taking your upload speed or downlink speed, then there won't be this minus value. Whatever the value you got, you can do. And enter any one value. Don't enter all the three values and don't go it. Either enter any one of the three values and go for the radio coverage map. Okay. This CSV file, whatever we prepare, it will accept any one value at a time. Okay, not all the three values together. Okay, now I'm going to upload the data. So here, upload, see, data underscore Chennai Nagar route dot CSV uploaded my data. Okay, so after uploading, okay, so this is the coverage map. I'm getting around the Chennai, I'm getting one zone. Okay, I'm just moving on that area. Okay, so this is my Chennai Nagar. Okay, so I've taken some 34 readings. You can visibly, you can see the 34 readings. Again here, okay, you can see the very light blue value or no signal, and very dark blue value. So dark blue value means the signal is very, very weak. Okay, so that is minus 95 or minus 100, minus 110 dBm. All those are very dark blue value. Okay, dark strong value, and this minus 60 to minus 70 is the light blue, that is the very weak, that is the very strong value.
This is weak, this is strong.
So minus 60 to minus 70 is a strong value, and minus 100 to minus 110 dB is the weak value. So if you see here you have zoom in option, so you can zoom in and you can go very closer. Okay, so zoom in, zoom out. Okay, so after that, okay, after uploading this, you want to click on show heat map on option will be there. You want to click on show heat map, then you can able to see this coverage map, whatever you are visualizing here. Okay, so if I'm going to click on each value, okay, if I click on each value, it shows the location, and also it shows that RSRP value, whatever. So it shows minus 65 at particular, minus 79 at some other location. It shows the your whatever the tabulated value in the .csv file, it shows all those values. So after uploading the file, okay, So after uploading the field, there is an icon called show heat map. You click on the show heat map, then you can able to see this. So this light color blue values are strong values, and this dark color blue values are very weak values. And one more thing is, this dark color values, this dark blue color values, these are the values specifying that you are very far away from the base station. If this light color blue values means you are saying that you are somewhere very close to the base station. So if I'm very close to the base station, then I'm going to receive a LOA signal. That means my power is from minus 60 or minus 70 dBm. So 70 dBm RSRP value is very strong. If I'm going to stay away from my base station, then I'm going to have this very dark color blue value. So dark color blue value RSRP is minus 100 or minus 110. So minus 100 or minus 110 means I'm very far from the base station. That might be the reason, or there may be a lot of non-line of sight of signal. There is no LOI signal. Completely, it is a non-LOS signal. So this also you can take into the account. Next thing is, so once after seeing this radio coverage map, okay, now there is icon called show towers. Okay, you can click on that show towers. So now if I click on the show towers, so you can see your 4 icons here. So first one is violet color LTE. That means your 4G base station. Green color 2G base station, and UNTS is nothing but your 3G base station. Test center is at what place I have taken this reading. So I covered somewhere the distance around Chennai Nagar itself. So there only my lab is located. This test center is around the location. So I will be moving around some 1 or 2 meter. I will be moving around some 10 meter, close to few 5 to 6 meters around. I will be roaming. Okay, so that is my test center. So if I go this, if I zoom in, so I can see the location. You can see the circle here, orange color circle. So in the orange color circle, it shows you what are the nearest 2G, 3G, 4G base stations. So this shows the nearby tower. So if I expand it, if I zoom in, then I can see what are the in that particular Chennai Nagar area alone. The circle shows the complete Chennai Nagar area. What are the different base stations it is. So you can also see what are how many base stations 2G, 3G, 4G nearby you. That also you can visualize, and also you can create a coverage map for wherever your coverage you have taken your measurement readings. You created the radio coverage map over that area also. Okay. Okay, some of you, Budatia has mentioned that I have created, but still it does not appear. So what doesn't appear, I can't understand. How many readings you have taken?
I think he has clarified it. He understood it. I think so.
No, sir, it got clarified.
Okay, thank you. So with this, our first video session comes to an end. So first we learned how to install the Troy app and how to collect the data using, so 3 different data you can collect. One is your RSRP, your residual signal strength level, your upload speed, or your download speed. So using these 3 values, with the help of satellite latitude and longitude, you can create your radio coverage map on the online repository site for your location, and also you can visualize the nearby 2G or 3G or 4G towers around you. Okay, so based upon the radio coverage map created, so out of the measurements you have taken, for example, I have taken a 34 measurements, I can classify my signal strength. This is very strong. Strong means minus 60 to minus 70 dBm, and very weak signal minus 99 or minus 100 to till minus 120, 110 or 120 dBm. Average signal strength from minus 80 to till minus 100. These are my average signal strength. I can visualize my signal strength, and I can also come to a conclusion that based upon this strong, weak and average, whether I have taken this reading close to the base station or far away from the base station. Suppose if I'm inside a building, definitely there I'll be getting a very weak signal power of minus 100 dBm, because the signal will be diffracted or totally blocked by the building, so that the signal power will be very very weak, minus 110 or whatever dBm. If I'm going outdoor to the street, I'm standing next to the base station, I'm directly, the signal I'm receiving directly, there is no any blockage between the direct signal from my cell phone antenna to my mobile phone, then I'm receiving the direct signal. There I'll be getting a reading so close to minus 65 or minus 68 dBm or whatever else. Okay. So any doubt till now? We have completed our first demo session. So this you can give to your, so now all classes are going online. You can give this experiment to the students. They can create their own radio coverage map and they can submit this as an assignment or whatever else.
There is one query, Satish sir, from
Yes, sir. If we collect the data, so you are collecting using Troy app, you have to feed it in the .csv format, then upload it on the CRFO website. After uploading the data, click on the icon, show heat map. Okay, once you upload the .csv file, there is icon below that is show heat map. Once you click on the show heat map, then it will show. Suppose if you are taking very very less reading, then you will be seeing only 4 or 5 spots only. So better go for more readings, so that you can have, I have shown you for more than 30 readings. That's why I can show you the complete path covering a metro station and all the streets, whatever else. So go for more readings, then you can have a better visualization of your coverage map on the on your region. This is up to you. As I told you, suppose if you are in a driving, okay, you want to cover every base station. So every 2 kilometers you can travel, you can take whatever the nearest base station you can cover. So it will show whatever this one. So right now coverage thing is, I think till 100 kilometer you can cover it, no problem if you are in traveling. But that is not the use. So most probably you will go for, you will be choosing a single base station, you will be going, you will be walking and you will be covering surrounding that particular base station, you will cover all the readings, right? Okay, because here you are going to, the main objective of this experiment is, using this result, we are going to estimate the path loss and how much distance. So till now, I have taken some 34 readings. Okay, each reading will be at some certain distance. I want to know, my aim is to how to calculate the distance. One reading might be, I may be so close to the tower, might be 2 meters or 5 meters from the tower. One reading might be something, I'll be around some 10 meters, or I'll be inside my room, I'll be taken that reading. So the next objective is to how to determine the distance. The next I'm going to discuss that one only. Okay, since my objective is to, based upon the readings, I want to estimate the distance and path loss. I have concentrated surrounding a single base station, or the walkable distances around the single base station. Okay, so now I'll continue. How can we get the path loss? Yeah, I'll show you right now. So now I'll continue with my presentation. Okay, so with this, okay, we learned what is CRFO, how to register in the CRFO website, so how to upload your data and how to visualize the heat map and how to see the nearby towers. Okay, all these things have been covered. Okay, so far what we have done is collect the data using Troy, create a .csv file, upload to CRO and show the heat map. Okay. This is what we have seen so far. Okay. Now what I told is, based upon the experiment conducted and based upon the visualization of coverage map, how I am going to estimate the distance between my mobile phone and the base station. So the received signal power in dBm is nothing but transmitter power minus path plus. So this is a standard expression you all know. So PT is the base station transmitter power in dBm, PL is the path loss, and PR is your residue power. Okay, here I showed that path loss for urban micro hexagonal cell layout in non-line of sight condition. I have given one expression. Okay, before going to this expression, I'll show you. So there are different path loss model. Okay, this is reference is taken from IMT Advanced ITU Technical Report M2135. Okay, in that report there are four major classification, that is urban micro, urban macro, and next one is suburban macro and your rural macro. So four scenario reasons. So you will be in your city, or you will be in a local town, or you will be in a panchayat, or whatever else. So whatever the thing, it everything will falls in this four major thing. Now I've taken my readings in the Chennai zone. I'll fall in this first thing, urban micro, okay, this one. So here, if it is a straight LOS signal, then I can go for with this path loss. But in our case, okay, since in this micro case, I'll be receiving the direct LOS, sometimes only non-line of sight of signal, sometimes the mixture of LOS and non-line of sight signal. That's why I've taken non-line of sight signal. Okay, because here we have most of the times our signals are blocked by buildings and everything else. So non-line of sight, the path loss expression is hexagonal cell layout. That is whatever the towers we have used, everything, you know, cell reuse, but everything hexagonal pattern only. We are not US. So if you are US, then you can go with the Manhattan grid layout. We are Indian scenario, hexagonal cell layout. So this is the path loss expression. And shadow fading for urban macro is, it is a default 4 dB, and this represents the height of my base station, and the distance between my base stations are all the default values. What should be the antenna height in the base stations for this particular layout, everything has been given. Since my area where I took the test, it falls in this particular region, I have taken this path loss expression to evaluate my distance for a shadow fading of 4 dB. So you have in the two slides, for all the scenarios it is given. So you have to pick your own scenario. Okay, and you want to select your own path loss expression. My path loss expression for urban micro thing is 36.7 log D plus 22.7 plus 26 log F. So this has been used here. Okay, so now I'm going to estimate my distance. So everything comes over one particular thing. Okay, so how to determine this path loss? Okay, now this I'll show in the next thing. So frequency, whether if you are using a 2G, then you know your GSM frequency, or if you are going to use your for 4G data, then you know what 4G data for every location, whatever you'll be knowing your corresponding frequency. From there you can take your frequency. Okay, so with this, for the scenario 1, okay, this is the for 10 or 12 different readings I've taken, okay, for this particular scenario. So this is my latitude value, longitude value, my RS, RP value, just everything I've taken from my Troy MySpeed app. Here for a path law, for a transmitter power, so whatever the nearest base station, I've assumed a transmitter power of 41 dBm. Okay, for a frequency, I have taken a 2.32 gigahertz. So some LTE frequencies I showed you in the CRFO map. For my region, it was showing some Airtel, Vodafone tower. There, the uplink, downlink frequency, everything is around 2.2300 megahertz. Okay, something 2300 megahertz. So that's why my operating frequency I kept as 2.32 gigahertz. So substituting all those things in the formula, okay, transmitter power and everything. Now I'm estimating my distance. So if you see for a minus 108, that means signal is very weak. Okay, for a weak signal, I have a distance of around something around 1580 meter. At the same time, I'll go to the second, for example, the very average or medium signal strength is minus 80 dBm. So this is the very lowest signal RSRP I have received. For that, I am my distance between my mobile station and my base station is something around 250 meters. So based upon the signal level, very weak level, the distance is also increasing. Sometimes, okay, I might be so close to the base station, okay, but I will be severely blocked by the buildings. Okay, that means what? The straight signal is severely blocked by buildings and it is taking some other path. So all those paths put together, that's why it shows the increased distance. Okay, so if this non-LOS signal, it is arriving at some other paths. So whatever the paths it is covering, it is summing up all the distances. That's why you are showing a very high value. Okay, so from this you can roughly estimate your based on this radio coverage map. We are roughly estimate I am between the distance of some 500 to 700 meters between my base stations, or some 2 kilometers or 3 kilometers. So you are roughly estimating your distance based upon the signal whatever your mobile phone is receiving. Okay, so any doubt till now? So second scenario, this now somewhat for all the 34 readings, what I showed you earlier, for all the 34 readings I created the radio coverage map. For this I'm trying to evaluate the distance. So the same latitude, longitude, RSRP value, my path loss, okay, here also I get my center frequency and my transmitter power of same 41 dBm, because it in the same location I'm so showing for two different set of readings, scenario 1, scenario 2. That's why I'm not changing my frequency and my transmitter power. If I'm using some other base stations, then obviously transmitter power of that station will be varying, then this value will be automatically changing. So here also if I see, so I'm somewhat close to within 1,000 meter range I was there. I'm not crossed more than 1 kilometer. So I've taken this reading roaming one tower, one base station. It is in the walkable distance or covering in the range of only 1,000 meters. Okay, so in this, if you see the lowest value, I'm getting minus 71. So this might be the reading I've taken directly with the LOA signal. So I'm straight to the tower. Maybe I'm in the upstairs, or I'm in the outdoor. Directly I've taken the signal. So here my path loss this value, and distances I'm in the range of between 150 meters between my base station and my mobile phone. Okay. So with this, the first part of the video demo comes to an end. Okay, so with this we try to create a radio coverage map using Troy MySpeed app, and from the created radio coverage map, I'm roughly estimating the distance between my mobile station and my base station. So any doubt till now?
I think a few more queries were there in the chat
Oh,
box.
okay, yeah, I'll come to the queries. So uh, table A12 path loss formula, not able to open the web page. So what web page they were on? Okay, now we have sent the link. Okay, so where you will be getting that PDF. Okay, so now I think now all your problem will be solving.
I think prior to that, there were two more queries by Dr. Buddhaditya and
Yeah.
yeah, and Mr. Mayur. So please, if you could address them.
Uh, yeah. Can I get the question, please? What
So,
question?
Dr. Bhattacharya has the question that other than centers or states, can I see base station locations based on my city, not heat map? As I can, yeah.
Okay, here mostly in JRFO they would have been covered the major cities like Delhi, Bombay, Chennai kind of thing. So if you want the other major cities to be located, you can create this .csv file. You can send the CSV file, and we will be helping you and trying you to add the coverage map of your own location. Okay.
And Mayur has a question on how to know base station transmit power.
Hello. So some of you were asking that the test center is not included in the radio coverage map. Okay. So if you are contacting us, and we will be helping you to add the test center of your particular location. We will be helping you. Okay.
Thank you. Thank you,
Okay.
sir.
So with this, we'll move on to our second part of our video demo session. For that, okay. Um, Okay. Now next thing is now shadow. So shadow fading, and so whatever we have done so far is shadow fading only. The same thing you can, okay, do the one thing you did by Troy My Speed app. Okay. One more app is developed by our Chandhar Research Labs. Okay. Shadows Lab app. Okay. This is the name, Shadow Labs app. Okay, the same app you can download from the Google's app. Okay, I'll tell you how to operate on those lab app, and you can create the same .csv file. Okay, now you can upload the CSV file. Now you cannot upload directly to the CRFO website. We have developed the equipment called YGuy. In that equipment, we can upload this .csv file, and we can visualize the PDF of whatever the residual signal distribution. So for that, first, just a minute. I'll switch over to another video. Okay. Okay, there is one more app called Shadows Lab app. Okay, right. So this is Shadows Lab app. You can download from the Google's app. You can download this app, and once downloading the app, okay, same thing. You can switch off your Wi-Fi and switch on your mobile data. So unfortunately, right now in this app, we have not uploaded the latitude and longitude. That process is going on. So probably within a month's time, we'll be uploading that, so that you can see, visualize latitude, longitude, and RSRP values, everything on that. But right now, if you are installing it, you will be able to measure only the RSRP value. You cannot able to measure the latitude and longitude options. Okay, so right now, once you install the app, so this is a front page of the app. Okay, if I click on this app, this will be, sorry, for example, this is a front page of the app developed by Chandhar Research Labs. So just click on this instructions. Okay, so if we think is how to use the app is, just there will be a recording button will be there. You have to click on the recording button. Okay, just you can take a step and stand in that particular point for 10 or 15 seconds. Then you can move on. Then go to a new position, stand over there. Then you can again measure. So like this, you can go on collect for n number of samples. So the major difference between the Shadow app and the Troy app is, in Troy app, when you are beginning the test, you would have seen the RSRP value fluctuating, some minus 109, minus 110, minus 111, like that it is fluctuating. Once you take the reading, then it is showing some default value of minus 110. So it is either it is averaging, or it is taking the entire fluctuation. It is not giving you the exact RSRP value. It is giving the average value of RSRP, or the one which is having the very strong RSRP value that is given in the Troy app. Whereas here in the Shadows app, you can take, it gives the RSRP instantaneously. So if you see here, to the main page, okay, here the recording button is there, the green color button, new recording button is there. If you click on that, okay, it starts measuring. Okay, it starts measuring the samples. So this shows, this number shows the 1, 2, 3, 4, what is the number of samples you are taking at every particular sample. So at this samples, I'm fixed, I'm standing in one position. Okay, now I moved to some other position, I'm standing in the same position. So now it is moved to 107. So I can see here the number of samples I can collect is, you can go for 100 samples, or 200 samples or whatever is, at every particular sample I'm recording, I know my correct def value. Here the values are not fluctuating. Okay, so every 10 samples and changing my location, that's why my RSRP value is changing here. So that means what I say is the RSRP values, whatever we are recording here, these are more standardized or more instantaneous than the samples recorded whatever you did in your triab. So there might be some applications or for some research purpose where you will be requiring for very instant values of your RSRP. In that particular case, you can go with the shadows app. Okay, so by using the shadows app, so whenever you are taking the samples, it's better to take for more number of samples, 300 samples, 400 samples, 500 samples. Okay, so at every particular sample here I'm getting the accurate and more instant RSRP value, whereas this is not possible in the triab. So if you are going to do any path loss modeling or any wireless communication modeling with the residue signal, if you are going to do any research work kind of thing where you require instantaneous values of RSRP, that time you can go with this shadows lab. Whereas Troy app is like user friendly, that is for like lab exercises kind of thing. If you want to research oriented thing, then you can go for this shadows lab. Okay, so with this I have nearly recorded for till 500 samples. Okay, I'm just keeping the values. Okay, so okay, I've taken for 300 samples, I think, roughly guess. So this shows the histogram plot. Okay, there is a once record you stop recording, it shows there are different options are there in the shadows lab. First one is histogram plot. So histogram plot, it shows the different values of your RSRP, the histogram plot of your whatever the RSRP values it has covered. So it is from minus 1152 till minus 94. And one more thing is whatever the shadows app I've used, this I used inside my house or inside my room or inside my particular layout. I've taken this. So this is under the complete indoor scenario. I've taken this shadows app. That's why my RSRP values are fluctuating from minus 115 to minus 94. You are not able to see any values ranging minus 80 or minus 60 or minus 65 kind of things. The same app if you would have used in the outdoor, then you would have got those values also. Since I've taken inside indoor, complete indoor scenario, the RSRP values are very weak values ranging from minus 94 to minus 115. Okay, next one is after histogram plot, this is a statistics plot of this one. So this shows the distribution of my RSRP samples. Okay, so the mean RSRP value and the standard deviation is taking roughly about 3.6. This I showed you right in Chennai metropolitan standard deviation of 4 dB. So it is this 3.6 is somewhat close to my theoretical value of that 4 dB. Okay, so now you understood why in urban micro you have taken a standard deviation of 4 dB. So if I take instantaneously the standard deviation, it proves to that model whatever I showed in the table last previously. This 3.6 is somewhat close to my 4 dB for my urban macro scenario. Okay, this one point can be clear here. Okay, next I can see the line chart of this is a line chart plot. I think this is something no. So if you are going for instantaneous values and you want more number of samples, I need. So if you see in this app, still now you are not getting any latitude, longitude position. So in some experiments or some research work, you may not be needing latitude and longitude value, but you are very peculiar about the very each instantaneous value of RSRP. That time you can go with this app. This gives the best RSRP values compared with your shadows lab. Okay, and one more thing is if the latitude and longitude right now we are working to update in this app. Once if it is updated, then I can use this .csv file. Then I can upload this CSV file in the CRFO website. Then I can visualize whatever the radio coverage map and everything else. But right now, since I'm having only the RSRP values using this app, I cannot create a .csv file. I cannot upload whatever the measurement taken here this in this year. So within 1 or 2 months or early 2021 or by the end of December, we will be updating that one. So once you get the latitude, longitude, whatever you did with the Troy app, same thing you can do with this, because now you are getting the latitude, longitude in the Shadows app, you are getting your RSRP value. Now you can use this data again in the CRFO website. You can create the radio coverage map or whatever we have seen here. But currently it is not possible because we don't have latitude, longitude values. Okay. Okay, so this is the second part of our session. So one more app we have seen. So when you're going for the instantaneous value of RSRP. Okay, so with this, I'll wind up the second session of this online demo presentation. Okay, I'm closing this. Okay, now the third thing is Vigai. You're presenting. Okay, so the slides are visible. Okay, somebody has asked how to access the .csv file created by the Shadows app. Once you complete recording is over, it will go to your files. You can go to the files where the Shadows app is there. So we have given the link: device storage, data, Android, Shadows lab. So there, that particular it will under some name, okay, year or time, .csv file will be saved there. From there you can take your .csv file. So any other doubt? Okay, I think no doubt regarding Shadows lab. So now we'll move to the third online video demonstration. Okay, Vigai. So Shadows. Okay, Shadows lab over. These figures are from the Shadows lab app. I have taken those. Now small scale feeding distribution. So till now we have seen the performance of live demo of your large scale feeding. Now we'll move on to the small scale feeding. So small scale feeding means obviously the multipath propagation. The signal fluctuation occurs due to the multipath components over a short period of time or very short distances. So the multiple signals will be there and multiple versions of the received signal at the receiving antenna. So obviously there will be random phase and time lag between your transmitter and receiver. The issues with your small scale feeding is, okay, one second. Okay, I hope now you can able to see the slide, small scale feeding distribution. Okay, so small scale feeding distribution, multipath propagation is a major problem. Signal fluctuations due to the multipath components over the short period of time and travel distance. So there will be a multiple version of your received signal at the receiving antenna. So multiple signals are receiving there, then obviously phase lag, time lag, everything present between the transmitter and the receiver. Major issues are intersymbol interference and Doppler effect. So the maximum Doppler shift is given by Fm is equal to V by C multiplied by Fc. So Fc is the carrier frequency and C is the velocity of light. Okay, so the received envelope distribution for your small scale feeding. So R of T, received bandpass signal, it comprises of your in phase component and quadrature phase component. So in phase component multiplied by cos 2 pi Fct and quadrature phase component multiplied by 2 pi Fct. So where the in phase component is given by summation of an cos pi n of t. Quadrature phase component is given by an into sin pi n of t. So in phase and quadrature phase components. So the total envelope residual power will be the sum of variances of your in phase component and your quadrature phase component. That's why it is twice that of your B naught, the variance of your single, either the one phase component. Okay, so with this small scale feeding, two different types of distribution is there. If LOA signal is present and non-NOA is present, then it is Rayleigh distributed P of x is equal to 2x by sigma exponential minus x square plus a square by sigma. A square is the dominant signal component or the peak amplitude of your dominant signal multiplied by your modified Bessel function of first kind and first order. When this dominant signal component is absent, that is A is removed, then your Rayleigh distribution is reduced to your Rayleigh distribution. So now how we are going to demonstrate this small scale fading? Before that, this is a Y-guy, okay, developed by the Chandhar research labs. Okay, this Y-guy is nothing but it is having an SDR, okay, nothing else, only the SDR operating from 50 megahertz to 948 megahertz, and the sampling rate of the SDR receiver is 2.7 mega samples per second. It is having a 8-bit ADC inside, operating at a gain of 19.2, and it has a Wi-Fi connectivity support, LAN support, USB support. It is having a RAM storage, RAM memory RAM of 1 GB and storage memory of 32 GB, and it is also have a GPS support. Okay, so it is a very user friendly device. It is programmed completely using Python language. This particular Y-guy, okay, it is having a remote access, so you can anywhere you can access this equipment, you can perform your experiments. It is a very low cost device. It is used for the collaborative training purposes. So now I'll show you the video demo. So this is a device, okay, so Wi-Fi device. Now I'll show you how to connect with this Wi-Fi device and how to lively see the demonstration of your small scale fading. Okay, so for this I'm going to play one more video. Just give me a 1 minute time. Okay, so I hope now the video is clear. I have already shown you the picture of the Y guy. Okay, it is somewhere remote, it is there. Okay, I'm using my laptop to connect with that device. Okay, it is completely working in the Linux environment. So this is my Linux terminal. I'm going to connect my Y guy device with my Linux environment. So first I'm going to connect my Wi-Fi through SSH terminal Wi-Fi, the IP address where this Wi-Fi is there. Okay, I'm just entering the IP address where the Wi-Fi is connected. So once it is connected, okay, it is asking for the password. After entering the password, it is entering into my Wi-Fi. Okay, so this is a Y-guy. So to open the list of experiments in the Y-guy, this is a command, Linux command, sudo bash main.h. Okay, this we are using it. So this Y-guy is always, you can work on that. You can move the generated files to a PC or an external storage, and it is capable of capturing samples in the frequency range of 50 megahertz to 948 megahertz. Okay, frequency is as per the user. You can enter your own frequency and whatever range you can do it. So sudo shutdown minus h, it is to shut down the device. And we have a LED indicator, and if there is a GPS antenna, so no need a separate location detector. So it is an inbuilt GPS antenna is there to take care of location. So better to use this device. If you want to use GPS, go close to a window and use it. So there is a LED indicator in the device. So two different lights, LED indication are the yellow LED means the Wi-Fi is capturing, or SDR, the SDR inside the Wi-Fi is capturing and processing the samples. Okay, and blue LED is idle. Okay, now what we are going to do is we are going to the demo directly. Okay, so before going to the demo. Okay, here I'm going to demonstrate the live demonstration of small scale fading from the received signals from my 2G base stations. So since 2G base stations, so I want to know you what are the active GSM frequencies around me, or whatever the active GSM frequencies around I'm receiving from my nearest base station. So for that I'm using the command KAL call minus is GSM 100. So GSM 900. So GSM, it is searching for the 2G active frequencies surrounded by me, where my SDR is operating. Okay. So there are plenty of GSM frequencies, channels are there. What are the active frequencies? It is just scanning for the active frequencies. So what happens after a couple of minutes? Okay, it is showing some channel numbers. You can see here. Okay, so channel 20, channel 24. Okay, GSM frequency 939 megahertz. That 939 megahertz, whatever the GSM frequency, it is having a channel bandwidth of 23.34 to 324 kilohertz, and it is a power of some 1771432. This is in linear scale. Okay, so out of this three frequencies, okay, out of this three frequencies, okay, so out of these three frequencies, based on the signal frequency, whichever is having the high signal frequency, I am selecting any one particular GSM frequency, either 930. Here I am selecting 939.8 megahertz. So afterwards, okay, these are the list of experiments available in the Wi-Fi. Okay, these are the list of experiments available in the Wi-Fi. Okay, so in this, the second experiment is verification of your small scale fading distribution. So what I'm going to do is I'm directly going, I'm entering the choice. So this 2 is nothing but the number of that particular experiment, because there only the small scale fading, okay, the Python file has been written. So every experiment we have a Python file there. The written Python file is there. That's why I'm entering my choice. Enter the choice 2. So after enter the choice 2, it is asking for the okay, it is asking for the experiment number. I am entering this one. So you can see here, after entering the choices, the verification of distribution of small scaling second experiment. Here two options are there. We have already set the default frequency in the program. So if I give 938.8 megahertz, whatever default we have set it, you are going to see the distribution for the default frequency. Whereas before going to the, I showed you how to scan the frequency and how to select the frequency whichever is giving the very good signal strength. If I am going to select the frequency, then I want to press N. So I'm going to enter my own frequency. I don't want to use my default frequency. Or if you want to view for the default frequency, you can press yes. So I pressed N, then I enter 940.6. So when I was scanning, I got 3 GSM frequency. In this 940.6, this particular frequency, I got the very good signal power. So for this particular frequency GSM signal around my SDR, it is processing the samples. Once the sample has been processed, okay, processing complete. Now I want to retrieve the files. So for that, FileZilla. Okay, FileZilla is the tool, or it is a app. You want to install the FileZilla app. Okay, using FileZilla, I'm going to copy my output files from my Wi-Fi memory to my computer memory. So this is the FileZilla app, whatever you are seeing. So here I want to enter the IP address of where my Wi-Fi is connected. So IP address of this, previously in the I've used the same IP. So the same host IP, using my username and password, and port, I'm mentioning my port number, quick connect. Okay, after connecting here, so if you see here, 2 windows are here. Okay, this left side is my my own computer or PC window. That's why home Sathish desktop. And this is the Vigai memory. So home Vigai, there are some plenty of experiments. 40 experiments are there. So that experiments. In that, this experiment 2, okay, because I entered the choice 2. So experiment 2 is for your small scale feeding. Just I'm clicking on this experiment folder, then I can right click and I'll have an option called, if you right click on this folder, there will be an option called download. Okay, you can see that one also. Okay, download. Okay, you can download, then that particular file will be, so this experiment file will be downloaded. You can see here in my computer desktop, experiment 2 file has been downloaded. Okay, so with this I'll show you the outputs. Okay, um, okay, so here the outputs have been saved. Here it I'm showing this. So this is the received signal. Small scale received signal amplitude have been shown here. Since I have collected this signal from a 2G base station, so it is a time division signal, so collected over the time. So you know that one TDMA frame or one time slot duration in GSM frame duration is 577 microsecond from the theory you have studied. So if you see here, these are the two deep nulls in my received signal amplitude. This is one null, this is one null. So if I take, this is somewhat around so close to 0.1 millisecond, this is something so close to points. And if I take the difference between these two things, this will be so close to 577 microsecond. That is one GSM frame duration or one time slot duration, whatever in your GSM frame structure you have studied, you will be getting. So these are the two nulls. The difference between the two nulls gives me the one time slot duration in your GSM frame, that is 577 microsecond. Okay. Now if you see the PDF, so this is the theoretical PDF, black color thing, and from whatever the received measured signals, this very light pink color, rose color is the residual signal amplitude. So this is somewhat matches with my theoretical thing, and this is completely Rayleigh distributed. Always I won't get the Rayleigh distributed. Sometimes if I get the mixture of LOS and non-line of sight components, this figure slowly will migrate. Okay, that time the PDF, this amplitude will be reducing. Sometimes it might go to the Rayleigh distribution also. Okay, so you'll be getting two different distribution, or sometimes in between the Rayleigh and Rayleigh distribution is also it's possible. This is the most standard and the default Rayleigh distributed curve is shown here. So with this, I'm winding up the third video session, that is online video demonstration of your small scale feeding using a Vigai equipment developed by the Chandhar research lab. So that's Vigai equipment, that yellow color one box session, nothing but inside you have a SDR. SDR is processing, ACAR of SDR is a, so that SDR is processing the samples and it is showing you the your received small scale distribution. So with this I'll wind up this session. Okay. In this session we have seen three different online demonstration. First online demonstration is using Troy app, how to collect the data, how to create your radio coverage map on the CRO website for your location, and from the created coverage map, how you are determining the distance between your mobile and your base station. Second thing is, we were using the Shadows app lab. You can perform the same experiment. Only thing is, Shadows lab app, you can record the instantaneous values of RS, RP, which is not possible in the Troy app. But one drawback of Troy app is, right now we are not able to access the GPS data. In future, we will be able to access that data also. Third thing, Wi-Fi equipment. With this equipment, you can run lot of experiments with respect to the fields of signal processing, analog communication, digital communication, mobile communication. And today I showed you the live demonstration of small scaling fading with the Wi-Fi developed by the Chandhar Research Labs. Thank you. Welcome for any questions.
Thank you. If the participants have any questions, they can ask now, or I would like to inform you that Dr. Sathish Babu will be conducting tomorrow morning's session at 10 o'clock. So if you wish, you can go through the experiments which he has demonstrated hands-on, and maybe tomorrow morning also you can post your queries. So I think there are no more questions today. So I thank Dr. Satish for a wonderful presentation and demonstration. Thank you, sir.
Okay,
And
thank you very much.
yeah, and we look forward to hearing from you tomorrow morning at 10 again. So just a couple of announcements before we wind up for the day. Number one is I had launched a poll in order to find out whether you would be interested in joining a WhatsApp group. It is not compulsory for this FDP. So depending on how many people want, I will take a decision, and if possible, I will send you the link tonight, today evening. So this is one thing. So you can participate in the poll if you wish. It's still on live, and it will be so for the next 10 minutes or so, and then I will exit the meet, and the poll will be closed. The second thing is every day in the morning you will receive a new meet link for the entire day. So that particular meet link will be active for the entire day, and this you will receive through your email as usual. So email will be the preferred mode for communication. And in case you have any issues, you can get back to me on my registered email ID. So with these two announcements, we will wind up for the day today. Thank you very much for attending. And tomorrow's session will begin at 10 o'clock. I will send you the meeting well in advance, maybe by 8:45 or 8:45 to 9 o'clock. In between, I'll send you the Google Meet link for tomorrow's entire day's free session. Okay, thank you very much.